let's go ahead and look at a second example here. As I say in the Algebra 1 videos, not that you've watched them, not that you should, I say at this point, like, since this is like a second example, you might pause the video right here and then kind of try to do it yourself, like figure everything out, and then come back and kind of see if we got the same answer, or check to see if you can compare work, or maybe you work along the same time, or maybe you just listen because you enjoy listening to my voice and you think I might crack a joke. Your call. Either way, let's go ahead and graph y equals 5 sine of 2/3 x. So probably there's at least one or two of you that's going, "Oh, Mr. Steele, why did you put a fraction in the problem?" And to which I'd say, because it's harder. That was supposed to be funny. It didn't come out funny. Just ignore me. Okay, so here we go. Let's start off with what you'd have. So you'd have a nice blank graph paperless axes, coordinates, or coordinate plane. And now we're going to start by analyzing this a little bit. So I'm going to do more of this in my head than I did the last time. So first off, for the shape, this is a sine curve, and in fact it's a positive sine curve. So if I take care of the reflection itself, it's going to start at the origin because it's sine, start in the center for being sine, and then it's positive, so it's going to go up. So we'll go up, then come back down. Okay, that's a gorgeous half a sine curve for being done by hand in Sharpies on a crappy little platform thing. And okay, this one's not as good. I spoke too soon. It's okay. It's not bad. And here we go. So we've actually graphed our sine curve's general shape already. And this is kind of like when you did quadratics back in Algebra 2. You got to get the parabola down. Well, you know this is a sine shape. This is how sines look. And so here we go. Okay, so sine and reflection, artistry is taken care of. Check. So now on to labelry. Phase shift, vertical shift. They're not here, although if we want to be kind of prepared for Monday. X equals 0, y equals 0. I'm just kind of label them, have them there. So now for period, so this is where it's going to be kind of involved. We're going to have to do a little bit of fraction work. Our period is going to be 2 pi over b, or 2 pi over what number's in front. So it'll be 2 pi over 2/3. Well, it's kind of hard to simplify for some of you. So think of this as 2 pi divided by 2/3, which, since this is dividing fractions, this is 2 pi times 3 over 2, which is going to be 6 pi over 2, or, just trying to find a good spot to write it in, 3 pi. So this wasn't exactly what I was trying to get it to come out to be. I wanted it to be even so I wouldn't have to do much work in the middle, but that's okay. So we find that our period for this function is 3 pi. So that's how long it takes for one full rotation from the origin all the way back to the origin that way to go through. So we go to our graph, and 3 pi plus 0 is going to be 3 pi. Over here we'll go the negative 3 pi. And then again, just to label the half periods, or just kind of get it in there, get those zeros taken care of in this case. Half of 3 pi is going to be 1.5 pi, or in this case, since we already got some fractions in there, that'll be 3 pi over 2, and this guy will be negative 3 pi over 2. Okay, so there we go. We've labeled that, so step 5 is kind of out of the way. Check. On to the amplitude. Again, amplitude will be probably the most comfortable. It's touching sine, so it's 5 in this case, or, excuse me, if I got to do this correctly, it's the absolute value of 5, which is 5. Remember, absolute value is the positive maker. In this case, it was positive anyway, so ignore that. And now when I go through, I label the minimum, the maximum values. I'm going to label this one with positive 5, this one with negative 5, and there we go. We've got our sine curve graphed. But again, if you don't trust me, I can believe it. So what I'm going to do is, let's go ahead and graph this puppy and see what we got. So 5 times, hopefully that's visible, sine of 2 divided by 3 times x. So I've punched in the function. Now I want to make sure my window is fixed. So going to my window, I'm going this time from negative 3 pi to 3 pi. So negative 3 pi. So notice I'm actually putting that in there. 3 pi. Well, it can go by 1, doesn't really matter. And then our max and min, well, since our amplitude goes from, or domain, or range, excuse me, goes from negative 5 to 5, we'll go from, I don't know, negative 6 to 6, just to get all the space in there. And then let's graph it and see if we can marvel. let's just set it right here. Let's just kick back, enjoy the ride, get ready to get really excited. Booyah! There it is. We've got it nicely graphed. We've got all the shapes, all the bumps line up. We're through the origin. We rock. And so there you go. So that was a short video, well, 2 videos that probably don't end up being short when you actually look at them all together, about graphing sine curves that don't have phase shift or vertical shift. And hopefully this has been helpful if you didn't catch it during class on Friday. Either way, well, you can't tell my thumbs up. Well, now it's sideways. Have a good weekend.